Okay.
Good morning, everyone. I am Namita Soni. Welcome you all to the second session of day one of AICTE ATAL sponsored faculty development program on Industrial Internet of Things. We are extremely honored to have with us Dr. Rajiv Agrawal, Assistant Professor, MNIT Jaipur. I heartily welcome you, sir. Dr. Rajiv Agrawal is Fellow of the Institution of Engineers IEI India. Dr. Agrawal received his ME from MNIT Allahabad and doctorate from BIT Mesra. He is presently working as an associate professor in MNIT Jaipur. Dr. Rajiv is having more than 20 years of professional experience. He has demonstrated his research capabilities in terms of research papers published and presented more than 60 research papers and various sponsored and industrial projects. He is a member editorial board in the International Journal of Business and Systems Research, IJBSR, InduScience Publishers. He is reviewer of various international journal of repute like Transactions on Systems, Man and Cybernetics Part A, Systems and Humans. He is actively involved in bringing industry orientation to the engineering education system in India, working with several industries, statutory bodies and other R&D organizations, demonstrating research capabilities in terms of research papers published and presented, including IEEE Explore Proceeding, Springer, Emerald, and Science Direct and InduScience publishers. Currently having various sponsored and industrial consultancy. Dr. Rajiv, currently managing a research projects, includes engaged in automation, Lean Six Sigma, supply chain design, and reconfigurable manufacturing system (RMS), and application of computational intelligence techniques on industrial engineering. One of the objectives of his research is to address convert quickly for the production of new product by providing customized flexibility and can be improved, upgraded and configured in response to fluctuating demands in industries. Now, I would like to request Dr. Rajiv Agrawal to kindly acknowledge the audience by sharing your experience and knowledge on the topic Industry 4.0 Introduction and applications. Over to you, sir.
Thank you, Namita, and thank you, organizers of SKIT Jaipur Department of Mechanical Engineering, for giving me opportunity to present this talk in front of all the participants and learned person all around India. I hope my screen is visible and voice is coming very clear.
Yes, sir.
Yeah. So this is, I think, second session in a day one, and you have already heard Professor Asif Tiwari about AI and aligned things. So this talk is primarily because this is the first day, so I would be giving all the possible application scenarios of Industry 4, and we'll be giving a one case study. The case study is their machine predict failures in trigger maintenance process. This was the one of our project which we handled at one of the steel company. So my introduction has already been narrated, and I will not go into this detail. Apart from there, I have handled these many projects, including the robotics, GIS technologies, self-organizing, adaptive learn, design, planning, operations, and manufacturing system. Then I was one of the coordinator for establishing MEMS Design Center. Then was one of the person for organizer for development of robotic arm for MIG and TIG welding. So these are the recent papers which published by my research team, and these are the very paper on 21 application of machine learning in sustainable manufacturing. another was the sustainability framework for Industry 4. Then these were the development of physical system for optimization and challenges of Industry 4, Sustainable Development Industry 4. So these papers are published in various journal and reputed conferences. My journey started in 2006 rather, and that was the first paper in 2009 actually, where I developed algorithm for multi-agent system for distributed computed process planning problem in e-manufacturing environment, where actually I handled three major agent: global manager agent, optimization agent, and design agent, which was a part of self-organizing algorithm, which we are talking now. So there are many, you can access this paper in Springer, which published in International Journal of Advanced Manufacturing Technology. So these were some publications just wanted to highlight. And now my presentation outline will be, I will be giving the how global various countries are doing and how India is doing in Industry 4. What are the various research scenarios and application of Industry 4? Then we'll be highlighting a case study. That case study will be discussed, very well discussed in detail, and you can easily understand how Industry 4 are being actually applied in industry. Then bibliometric analysis in Industry 4 learning in Scopus database. So I will be giving you highlight about how we researchers around the globe are working. So you can stop me any point of time and you can discuss, you can ask questions. It's very, so this is a two-way discussion. So the question is, the who is working on Industry 4 and when and where? So very important thing is, what are the data role in manufacturing? The first and foremost thing which I will be discussing in second quarter. So my talk will be in 4 quarters. First quarter is about dual scenario. Second quarter about data role in manufacturing and about Industry 4. And third quarter is case study, and fourth is bibliometric analysis. What are the features and how this research direction and what the current research effort is being done? And what are basic existing application field? Now, why Industry 4 is being put in manufacturing? Now, Industry 4 are being used by various discipline. I am what actually is more importance in manufacturing. So before that, I would be highlighting a work skill report published. You see this here. Mostly, it is talking about cognitive thinking, sense making, cross-cultural competency, transdisciplinarity, virtual collaboration. So that is, these are the work skills which are required in coming years. So if you see what are the changing nature of work skill. So if you see this working skill, so if you see this skills, now routine cognitive or manual jobs are now slowly decreasing, but non-routine cognitive and analytics are increasing. Demand for non-routine cognitive tasks has increased. So this is very big shift. Now, during COVID, we have actually seen growth pattern. This is why one of the report which published in Gartner, where enterprise and automotive IoT, we see all sectors, transportation, so if you see they are in negative, automotive, consumer. If we see then positive side, healthcare is on the positive side, foreign security, manufacturing in positive side. So these are the in positive side, and these are the negatives. So manufacturing is one thing, and health sector is another, which are enhancing with the help of IoT. Now let us try to understand how various countries are working and where Industry 4 has originated. So it started in 2011 in Germany. The first effort has started. And after that, now US has started one program called Advanced Manufacturing Partnership. So they try to develop an industry cooperative system, which is what we call 6S. So 6X is first space, semiconductor, shell, which is energy, smart ICT, silicon, sustainable talent pool. So from space to talent pool, so they try to make a roadmap of advanced manufacturing partnership. In 2012, Germany passed high-tech strategy action for 2020. And then UK had started in 2013, said future of manufacturing. So until the year 2050, they said call the future of manufacturing. European Commission has launched public-private partnership, which is Factory of Future in 2014. China has introduced this Made in China 25 strategy, Internet in 2000. So our plan of manufacturing is alternate to Industry 4 only. Then 2015, Japan has come up with Japanese super smart society by giving emphasis in SMEs and Aristo ecosystem. Singapore, one of the developed countries, which is committed 19 billion for research, innovation, enterprise in 16. These are the various countries. So you may be wondering, where is India? So India is not behind. India is also working in this field, where Indian government started this smart manufacturing technologies in 18. Prime Minister launched this Center for Fourth Industrial Revolution. In 2019, he established Samarth Udyog, initiative for creating an ecosystem for propagation of Industry 4 setup technologies. So they said key Indian scenario is planning, giving a 10 crore jobs and potential for manufacturing sectors in India till and both in manufacturing sector fold and third largest technology startup base in India. First, various Indian government department has made the initiative. First initiative from Ministry of Railway. So they made a collaboration with Coach Factory. They made a collaboration with IIT Kanpur as well. So which making transition of diesel using Industry 4. So their entire chain from design to production, which will helping in enhancing productivity, which may enable to take decision on real-time basis, minimizing human errors, for effecting monitoring resources and best utilization, and what is called overall equipment effectiveness. So you have to take these words very effectively while you are doing research, what you are planning with Industry 4 in manufacturing. So you have to use this, you have to take decision in real-time basis, minimize human error, monitoring this resources. So this is the first project first initiative by Ministry of Railways. So that they actually collaborated with IIT Kanpur, and that was the DST sponsored project. Basically, where comprising sensorization, data acquisition, signal processing.
Excuse me, sir.
Yes.
Excuse me, sir. Sorry to interrupt you. Sir, your voice is breaking little bit.
Voice is breaking. Okay,
Yes.
just hold on, sir. Just allow me to switch over to another internet. Just 1 second. Now, are you able to see this screen?
Yes, sir.
Now, voice is coming.
Yes, sir. Voice is coming.
Yeah. I was talking about this the project from ministry, and where basically has conceptualized this gradual expansion of Industry 4. Another initiative by Ministry of Commerce. So they establish a scheme that is called Smart Advanced Manufacturing Mission, which is Udyog Bharat 4. Is an Industry 4 initiative by Department of Industries, which will enhance competitiveness in capital goods sector. So this initiative is basically for Indian manufacturing industry demonstration center. So there is the 4 demonstration centers has been established. First is Center for Industry C4I4 is in Pune. Another is IIT D Foundation for Start Manufacturing. Third is ISC Factory R&D platform, and fourth is CMTI Bangalore. So another initiative by Ministry of Electronics was we are looking for a strong ecosystem across the value chain by integrating a global value chain, strengthening electronics manufacturing ecosystem. Third, another initiative by Ministry of Heavy Industries, where there are 3 technology department projects inaugurated. First from IC Bangalore, another CMTI Bangalore, third is SG Technology Scientific and Industrial Testing Research Center, Coimbatore. IC Bangalore has actually developed on metal additive printing with Department of Heavy Industry support. So basically, they're doing Industry 4 initiative in data analytics, 3D printing, AI, to machine, and it was CMT Bangalore. So they actually made a facility of technology of fabrication facility. So anybody who's working in Industry 4, they can actually access this facility with the help of Department Heavy Industries. This sensor technology is actually making products and machines smart for deployment. So they can actually design for data extraction. Another facility is for nanotechnology. So what center was SG College Coimbatore for the building robot. So development for smart submersible pumping solution. Now, apart from that, government has established 8 center of excellence for technology development. First center of excellence in CMT Bangalore was shuttle-less repair looms. Second, at IIT Madras for 11 advanced technology for machine and production technology. Third, PhD technology for welding technologies. Another for at Coimbatore for smart submersible pumping solution. And at IIT Delhi for textile machining. These all pertain to Industry 4. At IIT Kharagpur for advanced manufacturing. And Heavy Engineering Corporation, one of the largest machine tool public sector from India, for manufacturing hydraulic excavators with institution support from IIT ISN Dhanbad. And another center of excellence at IC Bangalore for design development of 3D printing technology. Now Industry 4 is converting digital factory with the help of 3D printing technology. So the government is advancing various smart manufacturing technologies. First is 3D printing smart gel changes shape when exposed to light. Transforming process using automation. And researchers are preparing tailored and wearable sensors with 3D printing UV curable certified. So during COVID, you can say that touching less, worrying less, doing more. That is one of the objectives in smart manufacturing. How 5G and IoT is bolster manufacturing sector. These are the aims which are now government has come up and advancing their centers. Apart from this, Government of India has given an award for 12 sectors, including Industry 4. So first was in 3D printing. 3D, one company has developed 3D printing with the capability of carbon fiber as the raw material. One of the innovation, you can search it. Second was in AR at wearables. It is enabling their experience without the need of writing any code while distributing through cloud and web. No app installation is required. But in the category of big data, here actually AI, which is the need of plant engineers, which is able to predict equipment and performance issues in advance before significant. Third, given in the category of computer vision, where wearable product is given to visual impaired for living. Basically, in three major areas: how learning, identification, and navigation. Fifth is given in the area of Internet of Things. So this was given in the area of energy efficiency. Using ML and AI to drive actionable insight. And one of the application in robotics where underwater remote operated vehicle. This was the one of the incubator or underwater inspections. These awards has been given by Government of India, Ministry, and in the various area where advancing of Industry 4 is going on. Ultimately, what we can use, there are two main. One is controllability is increasing, flexibility which is increasing. Now, if you use this side, so this as where requirement is you wanted to have long-term integration with flexibility and controllability is required. Now, till date, what you have seen, there are a number of labels which productivity model has established. I'm just giving you highlights. First is label 1, which is 5S and Kaiser model, which is called continuous improvement. So these are the hands-on label. Another is machine sim, where whatever design you are design is being designed, it has to manufacture. Data level, which will be in Six Sigma and lean manufacturing. So lean manufacturing is talking about reducing wastage, and Six Sigma is talking about reducing variation. You need to have data first, and then you are working this data to enable this. Another label is how you're predicting by analyzing this data. So this is what information label. And then with the help of this, you have to optimize and make the decision. Now,
Sir, Rajiv sir, I am sorry to
we have
interrupt
come
you.
to
Yeah, Rajiv sir, I am
Yes.
sorry to interrupt you. Sir, I think there are some bandwidth issues from your network. I request if you can switch off your camera so that bandwidth for the audio can be utilized.
just one second.
Praveen ji, are you getting the voice clearly? Because
No, sir, it's breaking.
I'm getting
sir, if you can
One
switch off your camera, I think the problem may be resolved.
Yes, I am just switching. Just one second. Just
Yes.
so now voice is coming clear.
Yes, sir. Yes, sir.
So I am talking about this label. Now, next label is about synchronization, which is now autonomous label, where data is, which you have data, which is not only transforming, you are predicting, optimizing, as well you are synchronizing this data. That is actually which is coming in label 5, which is synchronization. Now, one very important thing which actually is important, what is called data. Now, data is very important entity in manufacturing. What was happening in till date? What was happening in till date is what is a problem in factory? Whether there is a quality problem, whether there is a efficiency problem, you have to always rely on the experience and knowledge of your worker. And these people are having a certain craftsmanship. So they are actually building some relationship between what problem you are occurring. With the help of their experience, they are trying to find a solution. So what was coming till date is craftsmanship. The perfect product with the help of knowledge, with the help of experience. Now time has changed. Now, whatever problem is coming in factory, their machinist is actually designing the machinery, changing the various parameter to solve the problem. With the help of analyzing the previous data, they're predicting what is going to happen and how tool is going to behave and how tool will be going to work efficiently. You have to use Taylor tool live equation. Now you have a watched agent, which is predicting the machining hours, how much machining hours are left, and based on that, you are actually making that decision. So now, important thing which has come up is experience-based manufacturing now converted to evidence-based manufacturing, where role of machine learning, role of predictive analytics has increased. Now, that is what actually Industry 4, which is another word is called smart manufacturing, which is coming into picture. Now, previously what was happening in the customer is giving an order for 100 part to make. So if he is making order, so for making one part, there may be a number of steps for machining is required. Installation of setting of parameters, cutting tool, and running. So there are a number of steps requiring in one order. So you have to trace each and every step, and every 10 seconds, order will be data is being captured. We can understand this is about single tracing in every Now, this in 3 minutes, so you can understand how enormous data has to be saved. And it is 100 or data is being used enormously. So basically, this data is now becoming a faster. It has to be directly, you can actually, every entity is directly communicating with another entity. You are able to make decisions faster. And since it is a multi-dimensional, you can actually trace your order very effectively. Earlier was ERP, manufacturing system, SCADA. That is business level, full factory level, UES in business level, factory level, and process level. But which is the advent of Industry 4? Every entity is communicating with another entity. So basically, this data is produced sites. And what machine learning is doing, it is producing predictions, and AI will be giving a action. So I will be highlighting a one case study in just half an hour, how AI is producing action. We are trying to handle three simultaneously: data, machine learning, to have an insight, to have a prediction, and to produce the actions. The data role is predominantly in three major category. Say supply with these three entities, which call machine, product, and people, and this machine, product, people with customer. Here you want efficient supply chain, but with these three, supply to machine, product, people, you wanted to have an efficient supply chain. But inside this, traditionally, machine, product, people, you have a system that's called ERP. But you wanted to have a product from machine, so you have to have a competitive manufacturing. If you wanted to manage people, so that is talking about total productivity maintenance or TTM. Now, if you wanted to produce product, which will be enabled by quality control and PLM. Ultimately, these machine, product, people, and customer, which is having a relationship, which is called customer relationship management. These are the traditional data which being enabled. So just now I told about how data is being going to handle in Industry 4. I will be going to highlight right now. Now people are talking about IT is having a lot of data, but if you talk about data in manufacturing, this is the enormous data. This is 1,812 amount of data. That's called petabyte in manufacturing alone. So or us manufacturing, who is actually using large amount of data. Now we've talked about how data has been enabled or being executed. Now I'm going to give you how this data is being handled in various years. Now, if you talk about in 80s, basically data was, the quality was the main concern. We have a number of robotics and AI tools being used. It's not AI tools is using now only. 90s, people were talking about reducing not only wastages, but reducing variation as well. Lean is Six Sigma, reduction of wastages and variation, both. Smart sensor was the major role which has been. So another in 2000 era, another business focus is life cycle management. With methods technologies was prognostics. Now we are the era of 2010 onwards, where smart service and value creation, predictive analytics is the key. Where we are having industry 4, as I talking about agent. Agent is a software which is giving an autonomous action. So now cybersecurity, digital twin, these are the various technologies which is enabling start, service and value creation. Now, these are the things which just now we talk. But if you talk about, people are saying industry 4, so there must be some industry 1. Industry 1 was basically about mechanical production machines which are powered by water and steam, which was in 18th century. Earlier, how the production being powered through water and steam. Another development in industry 4, industry in industry 2, where mass production was the major highlight, which will be powered by electric energy. Industry 3 is about use of electronics and IT, progress, autonomous action, self-acting. Now, in industry 4 is where you can control your factory through app, which is based on cyber physical system. Where the level of complexity is increasing, as we know, data is enormously. We need to take the data, save the data, and analyze the data. So where it's from 18th century to today's, so industry 1 to 4 we have moved. If we talk about, I can able to show you how this today's factory is being compared with industry 4 factory. Basically, their main attribute has been taken is precision. At the component level, the precision is one. Data source is one of the sensor. Now, in today's factory, attribute is self-aware. So we are discussing about accreditation measurement. As I told about, agent is there, which is measuring the cutting tool, how it has been graded till date, and how much machining, efficient machining it can do for the rest of the period which is available. At the machine level, the industry for this factory was the attributes in quality and performance. Here, industry 4, where self-predict and self-compare. So my case study will giving you the highlight about this. So health prognostics is the key technologies here. Now, today was the factory is actually one of the output is efficiency and the productivity. So if you compare efficiency versus productivity, efficiency is basically actual output upon standard output, and productivity is rate of production. Here now self-reconfigure, self-optimize. So you may have one machine tool, maybe lathe machine, one machine tool which can work as a lathe, which can work as a milling, which can work as a shaping, and which may optimize speed in depth of cut for requisite machining. So you may have a very field production. Here data source are here, and the label is component, machine, and production system. We are moving in this era, from this era to this era. Basically, if you talk about Industry 4, it's based on connectedness, where machine interact and analyze real-time data. Now, if you collate all the technologies and evolution, so now there's one particular issue which is you have seen is radio frequency identity, which was in 80s, where electromagnetic field, which were automatically identifying and tracking tags attached to objects, where wireless sensor network in 90s, where sensor networks, monitoring, healthcare monitoring, environment sensing was the key. And now IoT, where interconnectedness of things, network infrastructure, and self-reconfig capability has come. So if you integrate this, you have a CPS, and finally, which we are talking is Industry 4, which is we are talking about interconnectedness of things, ubiquitous computing. You have to have a self-reconfiguring capability. We will be discussing with one of the case study into this, and I hope I am moving with the right speed and I may able to hear properly. So if anybody has any question, let me know. So no issue for that. Now, this is a one very important normal day in factory. Now, task production system is order for 500 piece. 1 week. Here, if Industry 4 factory is, I will refill the magazine. I can do the Saturday. Turn me on Saturday. 2 hours overtime. 3 hours validated Friday. Is empty, please refill. I got to be a good issue in 2 hours. And what human is being is saying, my barbecue weekend is cancelled. So that is experience to evidence based manufacturing. Now I will be giving you live example of Industry 4. Please hear this very patiently and try to make some points from this. This is one of the example from Industry 4. And just 1 second. I hope you are all are able to see. 1 second. I now.
Sir, is there any audio attached to it? Because we are not able to listen the audio with this case study.
No issue. I got it. I got it. No issue. Actually this particular is about operation. I will be giving you the live into this. Huh? This is one of the application for tire factory, which is Industry 4 enabled tire factory. I will be giving a live demo. I will be giving you how this actually factory is going to work. So this is factory is Industry 4 factory, which actually is doing a through Industry 4. So this is in Thailand. So where tire is being produced, where no human being is involved in, and where they were actually using a all latest technology. So if you talk about advanced factory, so there we have a neighbor who are actually using it. Here is whole process intelligence from, raw material to making a mixed rubber. Every operation is being controlled, monitored through network. So one location to another location. So automation process and intelligently operation being built. Here, you can see this where intelligent manufacturing is being enabled, and rubber cutting to taking their mixture. So each and every process is automated, and now you see this how this particular tire being rolled, and now tire has come the shape, and the testing is being simultaneously as well. Various testing is being made, then it's being transmitted through various sorting is being done, and the balancing line has been ultimately data has been filled, and finally you have a product which is actually raw material to finished product. So raw material to finished product has been implemented, and information is being shared in each and every cases. Here, as I told about, not only design but logistic automation is also being involved. Ultimately, it's providing intelligence in each and every stroke. So they're saying Tier 4.0. So that was one of the example which I have given. Since there was some data data lagging. So ultimately, the point of to show is how actually one factory has been enabled with Industry 4. So basically, Industry 4 is not only converging IT, but it is converting OT, operation technology, to create cyber physical environment. What are the key areas in Industry 4, where people in manufacturing areas are working? The first is manufacturing operations. There is original overall equipment effectiveness and about productivity. Third is predictive maintenance. Now, another is real-time equipment and process monitoring. So I will be talking about case study in this, and one of the key areas is automation. So these are these areas which Industry 4 are working in manufacturing. So real-time quality monitoring is one of this. So now, if you have to look this particular diagram very effectively, so you wanted to understand research gap with the current manufacturing system in Industry 4. Now, current manufacturing is about if you are using single automated cell, then you are here with the flexibility. So digitization, communication, standardization, and flexibility. So what are the gaps are here? So this is about responsibility, predictive, decision making, early aware, self-optimization, and self-organization. So this has been divided into category. One is manufacturing concept, another is Industry 4. So Industry 4 is about decision making, early aware, and self-configuration. Now, if you talk about automated assembly, this is the gap which we having with. That is the gap which we are having. Now, FMS is having a gap from customization to self-configuration, and SIM is having a gap from standardization to self-configuration. Now, RMS, which is now filling this gap, and which is now coming into filling the gap of self-organization, self-configuration, and making a decision making. So these are the research gap which you as a researcher is going to see and going to fill this gap. How various manufacturing from single automated cell to reconfigured manufacturing, how these manufacturing system is having a gap and how you can fill this gap. You can work on these areas. So basically, Industry 4 is bridging the physical and digital world through cyber physical system and is being enabled Industry IoT. This is your FDP for this week. So Industrial Internet of Things. Now, in next half an hour and so, I am going to give you case study of one company, one steel company, where machine which can predict failures and can trigger maintenance process autonomously. So we will be doing this, and there another operation where you can work. How you can actually work in these area, self-organized logistics to unexpected change in production. This is one of the research area you can actually work. So this is one company where Siemens, who's actually had got a plant in Germany, reported a 99.9985% production quality rate. So that is what one of the objective in Industry 4, to have a simultaneously getting the efficiency as well as productivity and as well as quality of 6 Sigma, which is 3.4 defects per million. Now, this is one machine which I am talking about case study, which machine which can predict failures and trigger maintenance process autonomously. Now, before that, I am actually going to give you some highlight of new one word which you are going to hear now, which is called automation. On touch. At the end of this talk, I will be giving you new word where this research is leading, where this evolution is going. So you may be wondering So there is Industry 4.1, Industry 2, Industry 3, Industry 4. Next, please go thoroughly about this case study. Basically, is self-diagnosis as quality control measures among automated lines in referred as automation, where human touch is the main thing. So automation basically allowing process to be able to make own decision. So independence of automation, and it has got a multitasking also, where operating is sitting with each machine, waiting, searching. One operator could have multitask watching several machines. And as I told you, increasing quality and productivity. So this word has another synonyms called automation, is another word called Zidoka. That is, automation is English synonym of word called Zidoka, which is the pillar of lean manufacturing, which focus on quality at source, where machine is equipped with abilities and function to detect dysfunction by itself. So if you say in nutshell, automation is a autonomy in automation or automation with human intelligence. This concept was developed with the main reason. So waste of time of further manufacturing, waste of time in transporting defective material, waste of time for defective processing, and inventory waste. Now, if you see what there are three diagrams which has been given. The first is manual feed, and so manually one person is feeding raw material to here. Here, if you see this person, he is watching the automatic feed of raw material. So automatic feed through one machine, and he is watching that. If you have self-monitoring machine, any part has some defects, so there will be and light will switch on, and it will have an automated rejection. So self-monitoring machine. This particular quality has two major issue. Now, whenever any technology, so you see two things. One is cost, another is time. So cost and time is a two pillar of anything. So where cost is on Zidoka, we have now talked where machine separation, standardized work, Kaizen is the one. They are the pillar of this. And here, now if you are working in this time where tough time and Muda, these are the pillar of delivering time. So that's the basic is stability with the help of. Now, if you see the whole cycle of automation, first machine is detecting error. Now, once machine is detecting error, line has to stop. Then fix immediate condition. It should not come again, so you have to investigate root cause. Then you have to install countermeasure. Again, it will go back. That is what exactly the whole cycle of daily improvement. So without stopping a line, how you can actually fix the problem? That is also one of the takeaway. Now, if you compare this with conventional automation, now I am just going to compare automation with automation. So automation is about people. Manual process is sometimes easier, but it requires humans. Their supervision can multitask, where human intelligence will be there because will be now you are saying here supervision is there, and here human intelligence will be there, automation. In machines, it completes a cycle until stop button is activated. But here, detection of error is autonomous. Then defects can be produced in mass due to machine malfunction. Here, machine crashes are prevented by auto stop. Defects are avoided. Then diagnosis errors are discovered later, and then defective part, you have to have the root part why this defect has occurred, where errors are discovered and corrected quickly. So key takeaway is automation is talking about supervision and automation is about human intelligence. As I told, this study implemented the steel company where the long-term benefit of automation in automated line was there. So there was some review has been done where this image acquisition system for identifying non-conforming material and some review has made. This literature review continued for generating warning of rules, automated equipment operation, and then cost reduction, medical errors in healthcare, and so on. That has occurred. Research team member has visited one steel company and then he did the literature review, exhaustive literature review, and very few application of soft computing based tools in automation area of research. That is the first research gap has identified. Second research work is relating machine intelligence to automation were not found out. Automation. So machine intelligence to automation were not found out. After that, the process has been laid out. So identification of quality related problem where automation is an appropriate tool. Then there was development of standard automation approach with the help of soft computing tool to enhance machine intelligence. So which was applied in industry and then finally it was simulated and applied in control system. This work plan has been laid out like this: literature review, then identification of research gap, then visit to factory, then development of automation approach. That was the one takeaway, and finally simulation. So you actually can see how the problem has been handled, tackled, and solved. First was how the rolling mill, that is the actually case study, was implemented in steel companies. They were producing a rolling mill. That was, so we will not going to see the details of this, but I'm just going to give you highlights. So that raw material was the billet, and it is going through various process, reheating furnaces, descaler, intermediate mill, pre-finishing, no twist mill, water cooling system, and laying head. Finally, this is the final product which is coming through by processing through various stations. So that was the process flow in rolling mill. Now, there was defects has been classified into two major areas. First was the metallurgical practices, another was improper mill practices. So in metallurgical, pipe, blow hole segregation. So whatever roll has been produced, so that roll has been inspected, and these defects has been classified. So these defects has been classified in two major areas. One is metallurgical, another is improper mill practices. Improper mill practices where scratches was the one. Scratches was the one. Now, scratches is the one defect which actually took, and this particular quality issue problem has been tackled. So out of these metallurgical and improper mill practices, this issue has been tackled. So those rolling mill is thoroughly examined. Now, if you see these scratches, this is the rolling mill where you can see the wire rod is actually it's got a scratches here. And this is the scratches which is coming here. So these are the scratches which was coming up. So these scratches, you can see this. Whatever product is being made through this wire rod. So here the product has got a scratches in this. So the final product also be analyzed, and these scratches has been. Now, basically, this has been analyzed why scratches being occurred through rolling, because the process, the billet was there, and it is going to various paths: box pass, oval pass, round pass, the rolling direction, and the final test has got this pass. So this basically the issue, which is the wire rod is going to various processes: roughing mill, intermediate roughing mill, intermediate finishing mill, and so various mechanism processes is being analyzed. And after analyzing this, the three major things has come up why scratches are being occurred. First was the speed difference. So there was a speed difference between roller and this wire rod. So this is the entry speed and this is the exit speed. And the cross-section area is being given by Fn and speed of metal is being given. So there is difference of speed of roller and rolling bar lead to scratches. Now that is the first coming up scheme actually. Another was impact force. Due to high ductility and collision at different points, you can, this is the wire rod where metal rod is there and which is actually moving, where scratches are coming from these two places, groove sharp edges. The first was speed difference, second was impact force, third is temperature. Now ductility of bar is gone by temperature and preheating furnace, where ductility is directly proportional to temperature. So speed difference, impact force and temperature. There were three major issues which has come. Now the question came, how to avoid this? So for avoiding this, we have to make a system autonomous. For that, fuzzy logic was used to increase machine intelligence. So that was the since these has got many issues, but I'm going to give you the very basic issues where rule based if x and y. So if input 1 and input there, and output may be this, or maybe the output may be this. You may have a number of outputs based on interpreting fuzzy interference system. So we need to solve the control problems. This is the fuzzy logic controller, which has got an input of temperature difference. If any is there or any impact force deviation is there, so it may have a 2 output, and now means the light which will be giving a output in terms of light, giving a warning signal, or it may be giving signal to stop. So I'm giving you only one part of this solution. So there are, because complexities has increased, so I'm giving a very simplistic solution. So it generates a predefined control action by fuzzy intelligence system. So it is using a instantly inputted fluxure line. So my question may arise, why fuzzy? And what is fuzzy? So fuzzy has handling a crisp values, and it has having some membership function. So that is called fuzzy fire, and it is going into interference engine where if then rules. And finally, defuzzifying and crisping value, which is coming in the output. So this actually, in a nutshell, you can say the fuzzy logic. But why fuzzy? Why fuzzy? So basically, in fuzzy, you can actually embody human thinking into control system. So it can emulate human deductive thinking. And it can actually, so traditionally, if you need to solve any problems, you may require a formal modeling. If you wanted to have traditional control approach, you wanted to have a, this is a real life problem, real industrial problem issue where formal modeling was the one of the issue. So that is this problem cannot easily represented by a mathematical model. So if you are using any kind of soft computing tool for enhancing machine intelligence, so you need to diligently use why you are using this technique. Now, as we now just now came to know, there was input, which is a speed difference, temperature, and impact force, which has got a fuzzy rule base, which was developed in MATLAB. And there are 3 output, low, medium, high, 3 rather input of speed difference, temperature, and impact force in formal natural language has been given. And then these inputs are being processed and giving the output. As I told you, 2 output. One was up and down, another is stopping. I'm just giving you highlights, the fuzzy inputs, speed difference between this moving wire rod and the rolling bed. This is the rolling bed. So this is actually a picture where cooling is also being done continuously. And second was the temperature, which is using in reheating furnace. And third is the impact force, which measured by the sensors along the horizontal and vertical. You can see this is actually complete roll line, and sensors are installed each and every intermittent interval. Now, this is the output which has been taken by one of software called MATLAB, and where the fuzzy logic rule based, which forming and implementing a according with human experience knowledge. The speed difference is negatively high, temperature is low, impact force is low, the signal will be, there will be no action. Now, impact, this is one input, another input is high, low, and medium. But is if you have got a speed difference high, impact force is high, signal will be there for halting. And this is the medium where this high, then signal is halt. There are a number of positions which has been taken: high, high, low, high, medium, then halt. So you can see these various signal which is coming up. So ultimately, these outputs has come up, which is end-on audio, visual, warning signal, and line action, automated stoppage, and propagation line. You may discuss that, the correction of error, then presuming that was the part of policy of industry. So I am just giving a very simplistic implementation of this case study till this point. We just came to know how this fuzzy input and fuzzy logic rule base has given and how output has been recorded. Basically, as I told you, this is programming has been made in MATLAB with the speed difference, temperature, and impact force. Where end-on and on the line force, where has also two outputs. These are so I will leave you to once you will have a certain value has been there. So there are some data which I am not going to give you the details, but I am just trying to show you how this output is being shared. So that was the one case study which my team actually implemented, and that is implemented. And now for you can say the real machine learning application where they're trying to make all the operations enabled through intelligence of human as well. Now, whenever you are starting any research or you wanted to write any paper, so you have to do bibliometric analysis. So you may do systematic literature review. If you have a certain questions in your mind. So was the bibliometric analysis industry 4. Now, if you see this, as I told you, 11 was the area where industry 4 came. Now, from 12 to coming to peak. So 20 is the peak. Now, since we are in earlier stage, so that is why this total data has been once 21 completely passed, then it will surely will. So documents are increasing year by year. So more and more research are working in this area, industry 4 area. That is the first thing. Now document, if you see the document is 5,000. So increasing document from 2 to 5,000 is increased. This is one database. This data has been captured through one database, Scopus. You can use many databases. I will tell you that also. So there are various authors. You can actually see authors who has contributing this. More and more papers are being contributed by these people. You can see how these people are working, which organization they are actually belong to. They are affiliated to various organizations. Now Germany is the number one. Yes, they have started Industry 4, so still they are the number one. Then Italy, United States, China, and we are also not far behind. So we are in top 6. So our researchers also working in Industry 4 area. Now, there are a number of different types of articles. So if you see the most article, there are book chapters, conference review, editorial, note, short, book, articles. There are conference paper as well, which is actually these are various countries. As I told you, this is the one database, Scopus. So Web of Science database is one, another is Scopus database. So a number of database, whenever you do any kind of literature review, so you have to take all the database. And then you have to diligently take the decision. So more or less these 4 countries are coming into picture. That was the bibliometric analysis, which is the 4th information. There are a number of references being used in these case studies. I have just highlighted here. Now, I am just going to give you the connected technologies and big data, which has used dramatically. Now, what is actually people are using? If you see predictive maintenance, next 5 years, if you want to do research in Industry 4, the predictive maintenance, you can use this, you can take this one area where this is going to develop or going to expand. So that is the one area. Big data, quality optimization, that is another area people will. Then visualization, automation, factory connected, integrated planning, data enabled optimization, digital twin. This is another word which is now very going to become a popular. Digital twin production assets, autonomous intra-plant logistics, autonomous digital factory. These are the area which are coming in the area and where you can actually do the research in these areas. So modular production assets. So as I told you, modular is one word where one production assets means machine tool. I talked about reconfigurable machine. So earlier you wanted to do turning. So lathe is the one machine which you are using. Wanted to have a shaping operation, then shaping machine. So modular is one particular machine may able to have number of machining operations. So that is one actually word which is called modular production assets. Now, where China has came from this, you may actually able to trace what is actually this is China World 2, the stadium they made. So they were so the country development and growth is being monitored through the how much steel they are using per person, how much steel they are using. So they are the biggest, not only producer, the user of steel as well. And we are also not lagging behind, we are in top 5 as well. So where actually you can start. So people, this is the first day. That is why this Industry 4 talk is basically giving you overview of all the global country which are doing, how India industry, how Indian government industries are working. They have established the various centers where you can actually access their facilities So ultimately, if you wanted to do the work, you need to identify the current processes, which I have highlighted to the case study, the steel industry case study. I have highlighted the scratches which will be coming. There are number two category with scratches. I have highlighted the scratches by improper mill practices being there. How those problem is going to tackle? Literature review has been taken. Then how this technology is being adapted. While adapting this, you need to verify the stages. This has been enabled properly or not. Then you need to optimize the various parameters to get not only good efficiency, but productivity as well. So basically, there are two major things which is important. One is cost efficiency. So people say, no, if I am going to implement Industry 4, so my investment cost will increase much. So you need to see what return of investment is this. As I told you, to maintain what are your strategies, machine monitoring solution, which this case study has given. So ultimate objective is any researcher is to how to decrease downtime and how to increase throughput. Ultimately, you need to reduce the cost of supplying quality. You need to reduce the cost of supplying. So this is basically important in manufacturing. I will be giving some question. How you have actually understood this talk and how you are. I'm just opening this. I have still 15-20 minutes available. I'm using that for one more model. So I'm just trying to ask you first question. What is the difference between Industry 4 and Internet of Things? And this particular talk has given you answer to that. Can anybody answer this in chat box? Can anybody answer in this chat box? What is the difference between Industry 4 and Internet of Things? I'm looking for interaction with you people, so that you can actually able to say. So I hope you may heard about this Internet of Things, which is yeah, I got one answer from Madhuri Pakode. IoT is a subdomain Industry 4. So let us try to understand this very, very effectively. Internet of Things is connectedness of people, process, data, and things over IT network. In difference, if you say Internet of Things is largely focused on connecting everyday consumer projects together. And while Industry 4 is much more focused on manufacturing processes, creating smart factories leading to smart products. So it is not enabling connecting to machines, equipment, one element of Industry 4. I'm getting another answer. I hope everybody is getting that answer. Second is, what is the difference between Industry 4 and IIoT? What is the difference between Industry 4 and IIoT? Please share your answer. Please share your answer. IoT is a component of Industry 4. And basically, it is an extension of Internet of Things into industrial environment. So industrial Internet of Things is the extension of Internet of Things into industrial environment. IoT solutions are the part of cyber physical technology, which is defining fourth industrial revolution. Now, I'm giving you very takeaway answer, which is called additive solution justice, additive manufacturing. I'm getting a very good answers with all of you. Digitizing business processes and advanced control system. So IoT is a part of cyber physical system, which encompasses additional solutions. Now, IoT is with additive manufacturing is a solution for Industry 4. So manufacturing is translating to improve sustainability, less downtime, more profitable across factory floor. So they want their component to be used for longer period of time without affecting future. Now I'm giving you some remarks how different government is working about invest in people in organization to develop future ready capabilities of industry. So I must congratulate ATAL AICT, where in the banner of ATAL, they are organizing of courses for giving dissemination knowledge, and IoT is one of the knowledge. Industry 4 is one of the knowledge which is being disseminated. So Malaysian government has implemented one program called Education 4, which is in line with fourth industrial revolution. So they are giving a education with the capabilities or competency required to digital driven industry. That is one program, Education 4.0. Now, this course is about IIoT. And in one which you are hearing in this talk, I am going to give you another heading, which is buzzword of that called Industry 5. So some may have heard about it, some may not have heard about it. This is the greatest advance which is now coming up, which is involving interaction of human intelligence. So where you are combining human and computerized machining, which are working to take manufacturing to new levels of speed and perfection, which has got a perfect cognitive computing. And this is known as a regard of fifth industrial revolution, combination of human and machine in the workplace. So I have given a case study where I have talked about human intelligence, that fuzzy rule-based has been made by human. So ultimately, the processing will be done. So ultimately, since morning, I heard Professor Seem for last some minutes, where some participant asked question about the employability. So you have, in this particular talk, you have seen where in Thailand, one factory, the complete process was automated and there was no human being was visible. So where Industry 5, where interaction human intelligence is coming. So as I have started with this talk, the work skill, future work skill is about cognitive thinking. Where more and more repeated job, work for repeated job will now going out, and then interaction of human intelligence. The job for cognitive type of work where human intelligence is required will have a more and more demanding. So this particular takeaway you may take, and this course is giving you every kind of input for enabling that future work skill for you. Please utilize your time. And as I told, I'm affiliated with MNIT Jaipur. I'm associate professor. Now we have one ad. So I have two positions available, where machine learning approach for sustainable supply for institute scholarship. Another is industry 4 enabled additive manufacturing without scholarship. So you may connect with that. There is another CRC book chapter. So where call for papers of a special issue. I am one of the guest editor in IJ. You can go to this URL and where blockchain technology for sustainable manufacturing based circular economy. This is Scopus Q2 paper, Q2 journal, Scopus Index journal. So this call for paper is open till 30th July. So by 1st August, you can submit your work if you are interested to publish your work in Scopus based journal. That is another call for book chapter in sustainability industry 4 and food supply chain. So it's being published by CRC Press. So there are a number of, you can say the dates has been passed, but you can actually still communicate with that. My research area is basically sustainability, sustainable supply chain, reverse logistic, and support with the help of various tools, MCDM techniques, statistical, Minitab in AI manufacturing, big data analytics, and machine learning. So with this note, I will thanking you all and open for question and answer. So I hope I am able to give. I am getting a questions. 1 second. I am just opening chat box. 1 second. I am opening a chat box. So let me see the chat box. How Industry 5 is related with IIoT? Yeah, obviously the basis are IoT only. Ultimately, the once your factory is connected, then only human intelligence will occur. So ultimately, these are the base. I'm having one more question. How we simulate IoT application for research purpose? Specifically, we wish to use blockchain or AI in IoT data. So you can see this is there is no such case studies and where you can say, yeah, this is the one you have to simulate this IoT application. So I have given you one case study in this talk where I have simulated one quality defect problem in MATLAB. So you can use this is one area where blockchain is one area. So you need to first understand the blockchain and then how this blockchain will be using this. So this is another area which you are actually for simulation of that. So I have used soft computing. I've used soft computing tool for simulating this. I hope everybody's has involved. So I somehow in starting of this, my voice was not. I hope you now after some time voice was clear. Can you discuss cons of introducing IoT in industry, data security, and other? So other point of view, yes. Now IoT in industry, as I told you, Internet of Things. 1 second, I will be giving you one. So introducing IoT. So cons of introducing IoT in industry, security, and other. So security is one of the issues. Now that is why cyber security is one area where industry 4 people are working very effectively. Now you can say cyber security where you need to understand. I given you one particular our one national awardee who has developed AI tool. I will be showing this. They developed the one tool without developing any kind of code. So people are coming and working in this session at different technologies. So let me come to this particular. Yeah, this is one where 3D and AR experience without the need of code. So AR and wearable products. This is actually people are working. Now, data security is obviously it's one issue where blockchain is people are predominantly using this. Now, another question is Industry 5 is totally dependent cloud. Yeah, whether Industry 4 or 5, your data will be in cloud. Obviously, cloud is the technology where the data is being is communicated with another device. So ultimately, human is given for that. There not a kind of question, but ultimately intelligence is being given by human. That is what the cloud technology is the base. So CPS, my talk is after day after tomorrow. So CPS, where I will be highlighting this, how this CPS is going to execute it, enabled. So I will be seeing another chat box. So what are the risks of Industry 4? So as Professor Aseem Tiwari, I will be giving a same answer. So like he has highlighted the same thing. You have a fire, so there are advantage of fire and disadvantage. So you have to diligently use that. Same thing, Industry 4. So Industry 4, ultimately, you need to have it two things together: efficiency and productivity. As I told you, if you talk about efficiency, the actual output upon standard out. Now you need to have these two things together while increasing your throughput and decreasing your downtime. The risk is which people are fearing. Now, one is high investment. So high investment is required. While having a high investment, you have to have a rate of input as well. But if you have optimized these three issues, productivity, efficiency, and cost issues, then obviously this can be enabled. The risk are the investment and the competency of people, which is this type of course. I must congratulate SKIT for organizing this, for increasing competency of people and making people aware about what latest things are going on. So there are yes.
Yeah, Raju sir, can I interrupt? Hello.
Yes.
Sir, will you please display again your slide where you have shown your research area open to the future potential PhD aspirants? Because one of the objectives of this FDP is to have a common platform where researchers and accommodations can meet. So I guess some students or future PhD aspirants can take a note of that slide because it was very quickly.
Yes. This.
Yeah. It was last to 3, I guess. Yeah. So the participants who are really interested in these areas, they can take a note of this and they can interact with Professor Agarwal even after this FDP. And if there are no any other questions, I request Professor Praveen Saraswat to deliver a formal word of thanks to our esteemed guest today, Professor Agarwal. Although he has very nicely presented a lot of things to the Industry 4.0, many of the concepts we have got a good idea of the concepts. We have read many of the things in the books, in the papers or in the other media, but when a live interaction is there, then it's phenomenal. So please, Professor Praveen, would you like to have a formal word of thanks?
Okay, then. Thank you, sir.
Yeah.
On behalf of SKIT team and family, I extend my sincere thanks to our guest speaker, Dr. Rajiv Agarwal, for sparing time from his busy schedule to grace the session. Sir, today we have an opportunity to hear your expertise in the field of Industry 4. The session was very informative, and especially the case study of steel industry was very knowledgeable. It will definitely put motivation in research work for some number of participants. Sir, thank you once again for your interactive session. I also thank to all the participants for attending the session and showing interest. Now, I request all the panelists to put on their camera for a group photo. Thank you, sir. So we
Okay,
will
Rajesh,
meet
sir.
next
Thank you.
next
I
session
will.
at 2 p.m.
Yeah.
Thank you. We would like to see you again, sir, on the
Yeah.
next session we have planned for you.
Sure, sure. Sure, sure, sure. So sorry for
Thank
some
you.
data glitch initial
Yeah, sir.
period, but
No,
I
no,
hope the
actually, yeah, sir. In the last also, even most of the time voice was breaking, but we could sense the concept because the video was there. But I guess there was some issue in the audio, but we will hopefully that in the
okay.
next session this problem will be resolved. Yes, sir.
Yes. Yeah. Thank you. Thank you all the
Thank you.
organizers and for giving the opportunity and all the participants to patiently hear. Best wishes for happy learning in this week.
So we will meet in next session at 2 p.m. The link is same for that. Now we are going to the this session.